Linux overview. It's going to be handy for new people. I think if you already know Linux, then you can probably skip this. But it's an interesting overview of where the world's coming and where the world's going. So, as you can see, the top three, they're old-fashioned Unixes. Solaris from Sun, AIX from IBM, and HPUX from HP. And the world is congregated around the Penguin. Linux Torvalds invented it. It's free. It's got everywhere. Red Hat and Ubuntu are probably the biggest two. And then obviously AWS is its Amazon Linux, Azure is its Azure Linux, and Google Cloud has its container optimized container operating system. And there's more subtle when you get into container world. So Docker or Podman, they create containers, and Alpine Linux is a really good version for it. And then we're actually going to look at ChainGuard, which makes the smallest images possible. So I've been doing Unix for 30 years. I basically designed global internet banking systems. And these were the types of machines we used. They're all about £1 million, and they're all about the size of a wardrobe. So the Sun machines, they ran a product called WebSphere, Apache, and Oracle databases. The IBM P series, they ran AIX, and they used them for WebSphere, Apache, and DB2. So DB2 is a database, the same as Oracle's a database. And the HPUX machines, we only ever ran Oracle in them. AIX, they had something called LPARs, or logical partitions. So you could slice the machine up into virtual machines. Pretty much like VMware now, where you can slice a physical machine into different VMs. And Solaris had zones, which has now become containers and Kubernetes. So the world originated there, and it's progressed. So where it might be £1 million to run one of these old systems, Red Hat came out, and there's the enterprise version called Red Hat Enterprise Linux we'll talk about. It used to be $4,000 a machine, which is obviously a fraction, and even if you sliced one of these machines into 20 or 30, it would still save you a fortune. And Ubuntu is the other, well, Debian is the main variety, but Ubuntu is definitely the easiest one to just use for doing your own stuff. So it got very simple. So on the right hand side, Red Hat came out first, and then Red Hat Enterprise came out after that, which was the solid one that got updated less frequency, and they made Fedora the version that got updated all the time, and it was free. So Red Hat was about $4,000 a machine, so the rest of the world went, oh, let's make a copy of Red Hat for free, and that was called CentOS. So everybody used CentOS for most stuff. IBM came along and bought Red Hat, and IBM deprecated CentOS. So the rest of the world have gone, oh. So Rocky Linux is now the new version of CentOS. So effectively, if you want the Red Hat flavour of Linux, Fedora's free, Rocky Linux is free, and Red Hat Enterprise is the expensive one. And Debian is the other one. Debian, lots of flavours come off that. Ubuntu's one that's nice and easy to use, and Raspberry Pi OS is a Debian flavour as well. macOS originates from a different one, and we've got the Amazon Linux and the Azure Linux are used in the cloud. Alpine is a tiny version, and Susie's been about for a long time. Susie runs on mainframes. It's got a version for mainframes. It's got lots of different versions, but they bought a company called Rancher, who are really big in the secure Kubernetes world. So Susie has got some really good Linux versions that work with Kubernetes that we'll look at in the future. So, and they've got two real big flavours of Kubernetes. There's K3S, which we'll use to experiment with in the Raspberry Pis, and then there's RKE2, which is the more secure one used by governments. So there's a list of commands. I'll just put them down. These are the commands I think you need to be able just to use Linux. So we've got things like ls-sale shows the hidden files, ls-lrt lists the files in order, so you've got the newest ones. But what we'll do is I'll write these commands down and we'll do various things, like so you make files and remove files, and touch makes a new file, head shows the top few lines of a file, cat holes shows the whole file, tail shows the end of a file. We've got permissions, tar, zip and gzip are all to do with compression. Text editors, you've got Vi and Nano. I think most of these will use Nano. I use Vi because it was the one about 30 years ago, so I use it for everything. Grep lets you do a subset of things. Find command lets you find things. So it's all obvious. I'm going to write a guide I learned from the Solaris 8020 guide. There's a link to that at the end. So what I'll do is I'll rewrite a modern one that's to do with Linux and to do with containerization as well. And it's going to make a lot of sense, so you'll be able to do your stuff. The variables in pink on the right hand side, star means everything. The pipe means put the output of the previous command into the next command. The chevrons, they mean write to a file or write to a new file. And dot is your current directory, dot is your directory above, and root is the very top directory. And then the ones on the bottom right, they're all to do with hostname, ping, curl and wget or browser, but they're all the network commands, and we'll go through them in a future exercise. So I just thought I would do a little diagram of a Raspberry Pi. So if you've got a Raspberry Pi and you put it on a 32 gig SD card, just follow in the Raspberry Pi installer tool. It splits the file system into various bits. So as the diagram on the bottom left, there's a root partition, there's one for devices, there's one for tempfs, and there's a boot partition. So in the top left, it shows you the actual partition slices. So the df minus h is a human read version of the file system size. So you can see of your 32 gig, 29 gig are available for the root file system. So the picture on the bottom right is an overview of the root file system. So nowadays on a small Linux system, all your files are in the one slice, and that makes a lot of sense. Previously, I had the machine that looked after the cow passports, and it was a Unix machine, and we had 360 disks in it, and they mounted to various directories. So you could mount /opt on an entirely different disk from /root, but they're all linked below the /root from a logical point of view. So that's an overview. So nowadays, basically everything goes in the root file system if it's a small box, and you probably use a SAN for your bigger storage files. But while it's fire and forget machines, because think with horizontal scaling, we'll do lots of machines, and if they fail, we don't care, we just rebuild them. Very much like the pets v cattle that we've been talked about before. If the machine's cattle, we just splat it and rebuild it, and it's all good. Here's a couple of the commands just to see what you can do. So you can make a directory, you can echo text files. Just have a play about. You can't do any damage. Time before a command tells you how long it takes to run, which is quite good when you're doing your tests. grep is good at finding files within it. There's host names here. Pi4822 is just my naming convention. Pi is a Raspberry Pi 4. It's got 8 gig of RAM and it's number 22. I've actually got 30 Raspberry Pis for when we do look at making clusters and stuff like that. So we can do powerful Kubernetes things or AI systems when we've got 30 machines. A Raspberry Pi is basically a Unix machine. If you don't have a Raspberry Pi, obviously everything we're planning on doing is we're going to use a virtual machine. Don't know if you've seen any of the other classes. If you get enough capacity for 4 gig of RAM on your laptop, we'll run it in a virtual machine. Just do the experiment and then splat at the end. It's a really good way of learning. And this is the document that taught me Unix 30 years ago. I'm going to make a version for Linux and container guides, but it was called the Solaris 8020, and it taught me everything I needed to know. And I think if I can add append at the end, I'll show you a wee picture of my Raspberry Pi cluster just now, but we'll go in a future version and look at it. Thank you very much.